Hello.
Sir.
Is it audible?
Yes, sir. Sir, this record start pante, sir.
Fine. The feedback.
Yes, sir. Form create pante, sir.
The link வச்சுக்கோங்க நம்ம லாஸ்ட்ல ஷேர் பண்ணி.
Okay, sir. பண்ணிட்டேன், sir. சரி, இது தாலே சாருக்கும் பிரியா மேமுக்கு அனுப்பியிருக்கேன்.
சரிப்பா.
ஓகே, ஜாயின் பண்ணிட்டேன்னு சொன்னாங்க.
ஓகே.
எஸ்.
Is it visible?
Yes, sir.
Fine.
Yes, sir.
Lokesh, is it audible?
Yes, sir. Yes, sir. It's audible, sir.
Yes, fine. So we,
Yes, sir.
we shall start in some next 5 minutes.
Okay, sir. Okay, sir.
Lokesh, is it audible?
Yes, sir. Yes, audible, sir.
Yes, fine.
Shall we
Shall
start?
we? Yes,
Ah,
yes, we shall start.
yes, sir.
Fine. The screen visible, right?
Yes, sir.
Fine.
Yes, sir.
So good
We can
morning,
start.
good morning, everyone. So I welcome all of you for this particular webinar on embodied carbon measurement for decarbonization. So myself, Saravanan, we have started sustainability webinar series from Innowell. So last month we have started with carbon sequestration, and in upcoming months as well, we will be providing the latest and cutting edge information regarding sustainability domain as a whole, with a specific focus on decarbonization and net zero initiatives. So this is about myself, Saravanan. I possess some 8 years of academic experience earlier to this. and a handful of courses, research articles, and patents. And I'm currently pursuing my PhD from NIT Warangal in environmental engineering. And myself, IGBC accredited professional and as well as a lead green associate. And currently working as a senior sustainability engineer in low carbon strategies at Innowell. And about Innowell, we have been here for more than a decade. So started humble with some 22 members in 2013, and we have been growing with offices spanning into 4 different parts: Hyderabad, Chennai, Bangalore, and Dhaka at Bangladesh. And they are our top orders and beloved director Gunasekaran sir and all other fellow colleagues, and specifically mentioning Mr. Thale Selvam sir, Deputy Manager for Corporate Sustainability. And we have been certified by USGBC as lead proven provider. This has been provided as an evidence of continuous commitment of Innowell in bringing up lead certifications for interior as well as new construction buildings. And of course, Innowell itself is being recognized for their sustainable behavior by EcoVadis with the bronze medal. And as of course, a couple of ISO certifications as well. And these are our playgrounds with MEP, BIM, and sustainability services. So we are providing design support in all these arenas. And these are our market segments, the type of buildings, and you can see the numbers on which we have proven our ability and expertise. This is the snap of our ongoing projects as well as completed regarding the sustainability. Since I belong to sustainability, I'm putting this. And these are our prestigious clients from India as well as from abroad. And Innowell is headed at Sivakasi. Yes, it's not in Chennai or Hyderabad. It's in Sivakasi, downtown village in southern Tamil Nadu. So we have been certified by LEED regarding the interiors of our office space with 97 points. Yes, we have proved that we teach and we practice. And this is our ambience of our Sivakasi office. And of course, if you want to have any collaboration regarding any of our services, and if you want to explore any research-based or any application-based low carbon initiatives or strategies, you are welcome. And this today's session is all about, we are going to talk about embodied carbon and how to calculate that and what all the tools are available, very importantly. So why it is important first, then what it is, then how it can be done. Then finally, we will have our demonstrations with possible number of tools, starting from software, web application, as well as mobile application. So what is the need for decarbonization of built environment? First, what is built environment? As you see, its man-made structures altogether can be called as or summarized as built environment. It can be included with buildings, transportation systems, but public utilities and amenities and communication networks, all together built environment. So what this built environment is behaving to the surrounding environment. So that says a survey about what is the energy being consumed by the so-called built environment and emissions which is being caused by the built environment. It's clocking around 35% regarding the global energy consumption, and 38%. 38 is not that accurate, but 38 to 40 we can say. So that regarding the global emission contribution by only the built environment. So on the other hand, we have our CO2 getting risen day by day. So starting very humble, and it is being folded growth in the emission into the atmosphere. So we are very much concerned about how to lower or how to nullify the CO2 emission into the atmosphere because of the built environment. So as a construction industry stakeholder, we are doing our efforts, we are doing our research, we are doing our collaboration just to bring up low carbon materials so that this contribution of 35% and 38% can be reduced gradually. So how long it may take? So we have fixed a target 2050, 2070. So it varies with the country to country, but in a global perspective, we have 2050 as the target for net zero, which means there is no new emission is getting into the atmosphere. So it can be done both by reducing the emission as well as balancing the emission. So right, carbon offsetting, all those things. So replacing all the energy intensive operations and the processes with some renewable energy input. So 2050 is the target, and we are all in a hurry to achieve this carbon limiting practices with our built environment within the 2050, which means around some 20 plus years are there. Only 20 plus years are only there. So how the carbon can be addressed within the built environment? We can split it into two: embodied carbon as well as operational carbon. So embodied carbon is happening with the product being acquired, manufactured, transported to the site, and in the site the construction is getting ready. That process is there. Once the construction is over, we enter into the operation stage, and during that we have another set of carbon emissions related to usage of the building regarding energy and water, right? So both together we can say it's a whole life carbon of a building. So embodied carbon belongs to material extraction, manufacture, transportation, installation, and of course the maintenance also will be there, which means we may replace, we may retrofit, we may refurbish. So all those things also would come under. Then finally the disposal. Once the building is getting dismantled, what is the fate of that? So including all those things, we say it as embodied carbon. Only during the usage of the building, we say the emission respective is operational carbon, right? So what we are focusing today is embodied carbon. And why we need to focus on embodied carbon more than operational carbon means embodied carbon is locked once the building is completed, which means once the building is constructed completely. The operational carbon will have a longer time span than the embodied carbon, right? If you take the growth rate of infrastructure development in global countries, embodied carbon plays the major role. Operational carbon, it has longer pathway over the period of, for example, if a building has the design period of 50 years, the operational carbon is going to be emitted gradually throughout those 50 years. But embodied carbon will be released once the building is getting ready, right? So if we are building more buildings, then we are becoming responsible for more embodied carbon, right? And we are having a goal in 2050. So if you considering that gap period we have, only 25 years we have, and within that 25 years, we will be supplied more embodied carbon into the environment. But after that also, there will be some operational carbon will be there. So more focusing on embodied carbon than operational carbon. That's the reason we have a fixed year. So we are started focusing on how to reduce the embodied carbon of the building, because once a brick is made, once a concrete is produced, the embodied carbon is locked. Unless you incorporate some innovative practice to absorb some atmospheric CO2 into your completed building product, whether it is a brick or a concrete block. So embodied carbon gets more prioritization, and these are the pathways we can address decarbonization in both embodied carbon and as well as operational carbon. So in case of embodied carbon, if you want to focus, you have to go for responsibly produced materials, materials with recycled content. Recycled content in the sense you can take off any waste you can take. It's a plastic waste, as industrial waste or agricultural waste. So anyhow, you are avoiding some emissions through the processing of those waste by incorporating into the new building materials. Then low carbon materials through R&D. All those things are contributing to how to reduce the embodied carbon. So during the construction or in the phase of construction, we may have the opportunity to design the structure with the whole life perspective. Then we can prefer carbon negative or carbon absorbing materials and working with green procurement policies. You see, so in the left side we have R&D, in the mid we have policies. So which means decarbonization is a holistic ideology for which you have to work both on the documents as well as in the on the field, right? So in the operational carbon, obviously we use energy and water. For them we can go for the renewable energy sources and managing the waste effectively. So that and all would contribute to reducing the operational carbon. So as a whole, you can incorporate some natural based solutions starting from the design phase of a building via the construction and to the operational as well. So today we are going to focus on embodied carbon, and these are the core ideology of how to reduce the embodied carbon. We name it as low carbon materials. In simple understanding, what is a low carbon material? If you are supposed to provide a roof slab of some 20 thickness, and you provide some intervention, technological intervention and engineering intervention, and you are finding out that your roof slab thickness can be reduced to 10 but it can serve the same purpose. So by providing the lesser thickness of a roof slab, you are reducing the carbon intensity of that particular material. So that perspective is nothing but the low carbon materials. So it's not only about doing some exaggerated research and coming up with some innovative and wow kind of ideas. No, low carbon materials are reducing the embodied carbon needs the optimization, design optimization. Also, we can do that, right? So understanding embodied carbon, first of all. So what is the definition? So we can have the embodied carbon of a building material as total amount of CO2 associated with the following steps. As I mentioned, production in the sense material acquiring and transport and all those things. Then installation or construction at the site. Then maintenance during the operation stage, then finally end of life stage, disposal of that material. So it can be dismantling and dumping in the landfill, or it may be a circular economy based upcycling also. So how we can understand these stages? So we have a widely preferred standard, European standard EN 15978. According to that, we have modules like starting from A1 to C4 and even D also. So the A means for the product preparation to the construction stage, and B is meant for the usage period, the operation phase of the building, and C is meant for end of life phase, right? So what are all the modules belongs to the embodied carbon. So we can say A to C4, which means A1, A2, A3, A4, A5, including entire B and C4, except what? Except B1, B5, B6, usage and energy use and water use, right? So all these modules contribute to embodied carbon. So if you are spending your investment or your engineering intelligence in the production of some low carbon concrete, you will be enjoying the benefits throughout the building cycle. So as you see, starting from A1 to C4. So only 3 modules are not going to participate in the embodied carbon because they will be additional energy we will supply. That is not because of the building material. That will be for our comfort. We demand the energy for using the fans and HVAC, all those things, and water. At the pumping and distributing the water along throughout the building, we need some continuous supply of power, right? So embodied carbon means starting from raw material supply to disposal, except usage phase. That's all. So how it can be calculated? This is the very theoretical or generic recommendation of calculating embodied carbon. First, you have to collect the data. What data? That's what we have told. Module A1 to C4, except B1, B5, B6. All the data you have to collect, which means what is the actual amount of material that has been acquired, what is the process involved, what amount of energy has been incorporated into those process, and what is the transportation, which type of truck they used and how much distance they traveled, whether it is an electric truck or a diesel based truck. So accordingly, what is the energy consumed, and finally during the construction, what are the machineries and all those things are used to construct that particular building. Then finally maintenance. If it is 30 years design period, for a period of 50 years, you have to do one time retrofitting. If it is a 25 years design period, for a period of 50 years, you have to do double the time, which means 2 times retrofitting or maintenance work. So all those things are also would come with some energy consumption. And finally, disposal. So if you want to what to say, upcycle your building once the end of life is over, which means after 50 years also you can dismantle and use in some other way, or no, we are going to dismantle and put it in the landfill. So all those things are also has to be considered, and the respective values has to be arrived. So that is data collection. So those data collection will be in two manners. One is energy consumption, another one is respective emission. So how much amount of energy has been incorporated and how much amount of GHG emission has been happened throughout all those processes. That is data collection. So in the data collection, we have two units, which means energy in joules and emission in different GHG values. So what we have to do, all those things has to be converted into single equivalent, CO2 equivalent, because universally we adopt the GHG emission is being conveyed and represented in the form of equivalent CO2. So that conversion has to be done. Then once the conversion has been done, you have to add all those CO2 emissions in all the processes. So the final thing you have to normalize, which means per unit of material, how much amount of CO2 equivalent has been emitted, like that. So this is the basic and very generic process of calculating the embodied carbon. So now you may ask the question, where I can find those data regarding the raw material extraction, manufacturing, all those things. How would I know? Only those manufacturers would know, right? Or if you go to a manufacturer, for example, cement to production, one of the famous producer of cement in Tamil Nadu, Ramco Cements, we can say and they may not able to have the actual data of those very initial activities like raw material extraction, how much amount they put it into those material extraction, the transportation, and all those things. So what is becoming mandatory nowadays is environmental product declaration, so that any product manufacturer can display their these data relevant to how much amount of energy involved and how much amount of emissions has been happened, right? So through those EPDs, we can get all those data. And what is the other way, sir? What in case of Ramco doesn't have an EPD for their cement? What is the other way? Other ways are nothing but literature references. So across the globe, people have published more books and research articles on the embodied carbon calculation of cement. So from there we can refer. Okay, sir, cement we can get like that. Cement is a very popular material. What about any recycled based new material? How we can get those those data relevant to that energy and emission? So the answer is, it is that messy. So we cannot able to find, or we cannot able to arrive those data just like that. So for that, we are depending on the tools which have been prepared and demonstrated by the experts and being approved by the world leaders or leadership firms. For example, regarding the green building, we can have USGBC as top-notch leader in global initiatives regarding the new activities. So they may approve some tools or some databases, so that from those databases and those tools we can get these data, right? So that's what we are going to see today. In simple term, data collection, conversion, calculation, that and all fine. In simple way, how the calculation of embodied carbon is done: the material quantity multiplied with the carbon conversion factor is equal to embodied carbon of that particular material. That's it. So material we have cement, 500 kg cement I have. What is the carbon conversion factor? So that I can calculate the embodied carbon of the particular cement. So here's the example I am providing for M20 concrete mix. So what are the ingredients for M20 concrete? Cement, fine aggregate, that is sand, then coarse aggregate, gravel, and water. So based on the ratio of M20, the proportioning has been done in terms of kg. So we prefer kg, right? Then what is the carbon conversion factor? And I have directly mentioned cement conversion factor is 0.82 kg CO2 of material. Material means here it's a concrete. Then fine aggregate, the conversion factor is 0.03. Coarse aggregate again 0.03. Water negligible. So finally what we have, embodied carbon of that M20 concrete mix is multiplying the quantity with the conversion factor, you get some kgs equivalent of CO2, and you sum up all those things. Finally, you will get total embodied carbon of M20 concrete as 316.4 kg CO2 equivalent. Now, the two questions are there. One is how you put directly carbon conversion factor as these values for cement, sand, gravel, where you found. That's the first question. Second question is why there is no conversion factor for water. That is also a material, right? But what is the universal assumption is, in the calculation of life cycle assessment, life cycle emission of construction or building materials, water is ignored, because water is assumed to be a naturally available source and does not have any carbon in their molecular structure. So they don't contribute directly onto the carbon dioxide emission. So we don't consider water for carbon conversion factoring. But the water can be indirectly affecting the overall emission of some processes. So there it may be preferred with some minimal value, 0.01 or 0.1, something like that, depending on the manufacturer's inputs, right? So as a whole, for construction material, we don't involve water for the carbon emission. So the second question is how you found those numbers, or where you could able to got those conversion factors, because I have these data in my hand readily available. So how can I do that? We will see. So there is a major source of embodied carbon database which is being referred or used as a base threshold universally, right? That is called inventory of carbon and energy, version 3.1. This database is highly specific to the UK, which means eastern and western areas or regions. But still, those values are getting updated on a regular basis in real time, obviously, and the updated versions are getting released once in a while by considering the average value of embodied carbon of a particular building material which is being available across the globe. So what are the materials we can have in the database? All those things, from starting from aggregate, mortar, ceramics, admixture, copper, glass, insulation, the flooring material, paint, paper, plastic, rubber, sealant, all those things. More very importantly, metals also, all sort of building metals. So let us see how that particular database would look like. So it is available as open source. Anyone can access and download. The circular ecology is the website, and you can go and fill the details and download the database, right? And this is what that database is look like. Lokesh, is it visible?
Yes, sir. Yes, sir. It's
Yes,
visible,
the
sir.
Excel sheet, right?
Yes, sir.
Yes, fine.
Visible.
So this is that ICE database, and we will have separate provisions of different materials and their embodied carbon. So material and embodied carbon value. So embodied carbon value means it is that conversion factor. That's what we have been talking about. So you will have the material quantity in your hand, and by referring this database, you will be able to identify a particular carbon factor, conversion factor for your material, and you will, if you simply multiply, you will get your embodied carbon of your concerned material. So aggregates by UK, and the best part of this particular database is for each material they would provide a detailed comments, so that by reading them you can appropriately prefer the particular factor for your region or for your indented process, right? So different material aggregates they have, expanded clay also they have, and all those things. Then aluminum, starting with aluminum metals, then all those things, aluminum, asphalt, binder content, then bitumen, then other metals, brass and other things, then mortar, which means brick, they made it for brick. So embodied carbon per unit, which means one brick, how much embodied carbon, like that they mentioned, along with the mortar also. And based on the what to say, the production method of the brick also, single skin walls, double skin walls, all those things. So you can likewise you can refer all the relevant embodied carbon value from this database. So with the cement, and very importantly, you may ask one thing, sir, in cement, we may add some other materials, sir, like slag and other waste material. So what about those waste materials, sir? How we can get to know about those conversion factors? So here they have mentioned the possible and most preferred additional materials as well. So which means 16% cement replacement done with some such mineral based additives. So GGBS and fly ash and natural pozzolana and all those things. And mortar, admixtures, ceramics, right? So it would come under, this is concrete. So on-site preparation as well as precast preparation they would provide, and depending upon the strength category also they would provide the embodied carbon conversion factor. So if the concrete is made with some cement replacement, that also is possible for 15% replacement of fly ash, 30%, 40% like that. So any major requirement for you to calculate an embodied carbon of a construction material, this database will be highly preferable, right? So that's how I could able to put those conversion factor here for cement, fine aggregate, coarse aggregate as well. So this is how the embodied carbon can be calculated. And for doing this, lot of tools are there, and that's what we are going to see. So what are the benefits of understanding and calculating embodied carbon? Obviously, we can able to reduce the carbon footprint of our built environment, and regulatory compliance and certification, because nowadays people are making mandatory to show on your carbon footprint of developmental projects. So if you have some 10,000 meter square grass floor area, what is the carbon footprint you have? What about the possible reduction you can have? Compare and come up with a better solution. Like that, people are demanding from the point of view of certification as well as the government regulations as well. So for that, obviously you have to do the evaluation of embodied carbon. Obviously, cost savings. As I told, the thickness reduction itself is an important strategy of reducing the embodied carbon. So by optimizing your design, you can obviously save a lot of cost. And market advantage, obviously, if you are a realtor and doing the infrastructure development, you can compete in the market by showcasing that you are providing a low environmental impact development. So, right. Then innovation and real leadership. So if you are being a company or a product manufacturer or a large firm in the infrastructure development, so by calculating and understanding the embodied carbon, you can drive innovation into the low carbon material development. And by doing so, you can become a leadership in that particular region. So, right. For example, we can have our L&T from India, right? So they are having a dedicated R&D center, and people are continuously exploring how to reduce the embodied carbon of most preferred building materials in India. So I can ask a simple question here. For majority of the buildings in India, what is the preferred material? Across India, you have to consider the whole of India. So it is not RCC frame based, it is brick based load bearing structure. So what would be the most preferred material? It would be the brick. So how we can produce a low carbon brick, whether it may be a clay based or cementitious based. So if you are doing that, you can be a market leader. So that's what they mentioned. And stakeholder engagement through transparency. So if you are able to calculate your embodied carbon of your proposed design, so that your customer or your continuous what to say business stakeholder units will be rely upon you for providing the low carbon initiatives, right? So the value, right, for whatever the things we want to finally know some numbers, right? If the number is low, it is good. If the number is bigger, it is not good, right? So that engagement can be provided by the proper calculation and communication of embodied carbon. So let us talk about those tools, right? What are the tools are available for calculating the embodied carbon? So as I mentioned, from software to mobile apps, these are the things are available. So first, let us talk about a software which is being used in at Innowell. So we prefer one-click LCA. So it's a software tool for whole building life cycle analysis for independent buildings or group of buildings. So what it does, it can simplify the complex, time-consuming calculation of all the life cycle stages for each and every material by automating it through the easy and comfortable and simple data input. So if you have what are the materials that you are going to incorporate for your project, and if you enter those material data into the software, it will do all those life cycle assessment by abiding the LCA framework as well as building LCA framework, and will show you the results finally, right? So that's what the best part about one-click LCA, and it is being preferred across the globe by the major, the players, and it is getting popularized day by day for doing the construction LCA. So understand, embodied carbon is a common term which can be applied to any product. If you talk about a beverage production, there will be some embodied carbon. If you talk about a fashion and a textile based business, there will be some embodied carbon. Here we are talking only about construction and buildings, right? So one-click LCA is becoming the popular software for doing construction LCA, right? And what are the other similar softwares are there in the market for doing the same construction LCA? Pro, very important one, and Open LCA, open source, and Gabi, Carbon Graph from Canada, and Athena Impact Estimator also from Canada, and Tally LCA. So all these are some emerging and preferred LCA tools regarding the construction, right? So except to OpenLCA, all others are you have to pay, right? So OpenLCA only is open source. You can download and install, and you can perform LCA. But as I already mentioned, what is the core of calculating embodied carbon? The data, right? The data belongs to the material procurement, manufacturing, transportation, and construction, right? Those data are called as data sets, are available only for the cost. Even though you have OpenLC as a free and open source software, you have to purchase those data set to accurately execute the life cycle assessment. But still there are some free data sets are also available, but we are regional specific. In India, in Tamil Nadu, in Coimbatore, I want to construct a 10,000 square feet building. I want to calculate the embodied carbon means, then for with the available free data sets, you may not able to incorporate those regional based materials into the software. So for that, you may have to go for the paid versions of data sets, so that somehow the regional factorization would have been done, right? It's not going to provide the materials and the embodied carbon of Coimbatore region, but still the Indian localized conversion would have been done in those paid data sets. That's what I want to clarify. One of such important and very popular data sets are Echo Invent. So Echo Invent is being preferred for the LCA softwares across the globe. Then carbon calculators, right? So these are all not like full-fledged softwares, but like online tools. So to tell you about how much amount of carbon that your project is going to emit. First one is construction carbon calculator from Build Carbon Neutral organization. So they are providing the tentative estimation. Yes, it's not so accurate, but still it will provide you some the ideological estimation. Okay, thousands of kg CO2 it may emit, like that it may say. So what is the accuracy? 25% plus or minus, which is actually highly undesirable, but still it's one of the important tool which is being preferred for the entire North America, right? So the Northern America developmental projects are preferring this particular tool for estimating. So that's what they are telling, estimating, not calculating, estimating their proposed embodied carbon. So this would be the screenshot of that particular tool. These and all are available as free. You can go and try it on your own. But this is the data that you have to put: the total square foot of the building, how much and how many number of floors above the ground, below the ground, what is the structural system, concrete, steel, or wood based, and eco region, which means the North America has been split into number of eco regions. So for the particular eco region, the data conversion factor would be different. That's what they mentioned. And put all those things, if you put and calculate, it will tell you how much amount of carbon your proposed project would emit. And it would also list out some hotspots where which component you can focus to reduce the carbon based on their local past experiences. And the next one is Kaleidoscope. Yes, Kaleidoscope embodied carbon design tool. It's also based on some western region, but they are limited with only envelope, flooring, ceiling, and partitions. They are not talking about steel, concrete, those major and load bearing stuff and all. So they provide only envelopes, flooring, but within the envelopes they would provide a numerous number of options. So flooring tiles, flooring options, ceiling in the sense uh, it's like not a permanent one, it's again a temporary or fall ceiling kind of this. Then partitions, temporary as well as permanent partitions, right? So this tool also can be used to differentiate about what are all the market available materials are there in the envelope, and what about their respective CO2 emission, embodied carbon, so that by by going through this particular tool, you can able to choose effectively. So you should understand one thing: in the previous tool, you can have a overall estimation, right? So then you would understand, okay, what are the things you have to proceed with the lowering the impact. Here also, it's not going to design anything for you, but it will compare and display the embodied carbon. That's all. Only comparison and displaying the value, so that you can make your choice efficiently. That's it, right? So that's the purpose of this tool. Then Carbon Designer 3D, one of the feature of one-click LCA. So one-click LCA is actually meant for full-fledged building life cycle assessment, but still this Carbon Designer will give you an idea about where there is a scope in your building design to reduce the carbon, right? So for doing this, you have to put all the in-hand data, like what is the total grass area, length, width, depth of your foundation, number of floors, and all those things. And it will automate and it will display the projected CO2, right? So we will have a look into this particular one later. Then web applications, all those things are carbon tools. Then finally web applications. Edge web app is there. It is a global green building provider or platform, we can say, International Finance Corporation from the World Bank Group. So they have Edge certification itself. Like how we have IGBC, Griha, and LEED certification, Edge certification itself is there. So for according to their that certification criteria and all those things, they have developed an web application. So there you can go and put all those requested data like building type, location, project details, building data, area, dimension. If you are going to use any HVAC system, what is the respective COP values and all those things? What is the fuel? What is the location specific? Which part of the world you belong to? So accumulating all these inputs, it will tell you the overall embodied carbon of your proposed project, so that you can understand, okay, in which arena we can focus and can able to reduce the overall embodied carbon. This is one of the edge web application, but still it's a bit slow. Anyhow, it is worthwhile to try. Then EC3, embodied carbon in construction calculator. This is again like in the previous Edge app, it will calculate, right? So here you can compare different materials from across the globe based on their embodied carbon. So, right. So then finally, Revolu is a web application again. It belongs to Scandinavian countries, so especially a specific part of European continent. So these Revolu, EC3 or Edge web app may not able to have the specific materials which belongs to Indian scenario. So that's what you should understand. But in Revolu, you can able to see 25 Indian originated products. 25, only 25. How large India is, right? Only 25 products are listed into that particular things, which means for 25 Indian originated products, we have authenticated data about the embodied carbon. That's the meaning, right? Then mobile applications. Let me share my screen for the mobile application. So these are all the overall mobile apps, not only Android, including iOS as well, which means Apple. And based on the country of regions, the availability in the app store would vary. So if you see something here, and if you search it in the Play Store, it may not be available, right? So that you should understand. So all these things are the majorly available mobile applications, not some college-based projects. It's a very serious and continuously evolving applications regarding life cycle assessment, regarding various aspects. As you see, e-waste recycling, travel-based embodied carbon emission, clothing, fuel, then different materials, lab solvents, chemical-based LCA, and farms. So in a farm, how positively an embodied carbon can be reduced, or how much it would be. So it's based on New Zealand, Canada, and Netherlands, and all those things. From India, no such app is available. It's a huge potential to for a new startup. So from this, we can have what to say, the 12th one, ID MAT, and 11th one, buildings LCA. So buildings LCA and ID MAT are focusing on construction related products and materials and their LCA, right? So ID MAT is available in India in our Play Store, Android as well as Apple. There you can able to see different building materials, wood, metal, and other materials, and their respective processes involved. As we have seen, the embodied carbon starts with raw material procurement, transportation, processing, all those, right? And those things would be available in that particular IDMAT app, right? And the highlighted aspect of that IDMAT app is there the energy consumption based on Indian scenario is available, right? That particular aspect may not be available in any paid data set also, maybe, right? But in that app, free app, it is available. It is actually developed by Delft Technological University. So they have, it's an academic based development, and they are continuously evolving on a daily basis. It gets updated with the material and processes, right? So we will have some demo there. Then finally, the demonstration. So I hope it is audible and visible, right, Lokesh?
Yes, sir.
Yes, fine. So let me share how an one-click LCA, the platform, would look like. Is the screen available?
Yes, sir.
Yes, fine.
Yes, sir.
So this is our one-click LC, and these are our projects, and we can have an idea about how it will look like. So you would need to start with adding your building material data into the respective place. So let me tell you. So add building, and you have to the page and all, the type, which type of building, the building typology, people say office buildings, all those things are available, and the location. And if you give next, it would give some first design and options, right? Let us talk about some apartment buildings in India, right? Grass floor area they are asking, so 10,000 for example. Number of floors, some 10. Frame type you can prefer not determined, or concrete or steel or timber, you can choose. Mostly it would be concrete frame for apartment buildings in India. And which type of certification you want to pursue, based on that they would optimize the final calculation, right? So that's the beauty of this one-click LCA. And lead for point one. So what target level also they would give? You want a silver certificate or gold or platinum, something like that. So always going for the maximum possible thing. So this would be the first thing, and you have to get start with the tool and the method. So international method of doing the LCA is the chosen one, because there are several methods are available to perform the LCA of any building. Uh, Location specific are there, but for Indian case, we have to go for the average one. So that is why we are choosing this international. If you are being a part of United States or Canada or European region, you can able to choose a specific LCA method for your own region. So your result would be highly accurate and highly dependable, right? But in Indian region, it's not available. So people are using the average executing method for doing the LCA. So again, you have to give the name and other things. It's a basic design. So which phase you are having, conceptual design or something like that. New construction or existing building renovation or interior project, based on the condition you can choose. And again, which frame? Concrete frame. So in your building, as we have from the foundation, superstructure, and exterior finishings, all those things are there. based on our interest, which has to be included, which don't need to be included, we can select. So foundation, structure, finishings, enough. No external area, no services. Services means HVAC and water related fixtures, right? So those and all would not be included. If you want to include, you can include. Yes, default LCA parameters. You can here also optimize, but still we prefer doing the basic thing. So now you have to input the data, right? So building materials. So this is it, right? So building materials, foundation, substructure, vertical structure means external walls and facade, column and load bearing, internal wall, horizontal member, beams, floors and roofs, and other structure and other materials. So what you have to do is you have to fix your country first. Yes, India. So that only based on Indian available materials will be displayed. So for foundation, what material we may have? Concrete. So it would come like this, you know, you will have lot of options based on Indian scenario. But these and all are Indian scenario, but not manufacturer specific. Right? That's the twist here. It is based on the existing literature, research literature, and existing usage and appropriate results. It's like a trial and error method, and so that they have fixed, okay, this is the value, this is the value, like that. And for each material, you can have the information as well. So background information, technical characteristics of the particular material, environmental profile, what environmental impact it would give, so like that. So all those things. So based on your choice, you can select and you can put the material quantity. So this is like for doing one click LCA, you have to have the bill of quantities for each and every material from top to bottom, in and out, right? So accordingly, you can put it here. And similarly, if you are putting all the materials in the respective boxes by choosing the Indian scenario, finally we can save and you can perform the analysis. So like analysis like nothing but results. So if you simply click the result, it would give the values of your like building area we got to give. Earlier we have given calculation period. So calculation period also you got to give. So how many years, which is nothing but 50-year design period. So 50 years or 35 years or 60 years, so that also. So now if you click the results, so we haven't give any material. So there we didn't mention the concrete course, right? Something, right? So for the time sake. So I have only made some foundational concrete, that's all, right? Nothing else I have made. So based on that, it will give the result. So this is it. So how much amount of CO2 it would emit per meter square per year? What is the social cost? And the environmental impact categories as well, right? So everything would be calculated and would be presented automatically. So module wise, we have seen that module, right, based on the European standard, A1 to D or C4. So based on the modules, it would give you the data, right, the results. So while inputting, while giving your the material detail, if you have the transportation detail also, you can input, or else it would automatically fix some average transportation detail for the specific region, right? So that only here then the transport some amount has been reflecting. right? And at the end of the life scenario also, you can choose whether you are going to dismantle or something like that. So like this, you can, so it's like a summary of the result. So total embodied carbon benchmark of your project is, only 7 kg. So what is the maximum for a lead certification? It is like, what to say, not going beyond 650 or 900 kg per meter square per year. If it goes beyond those values, then there is no meaning in going for a green building certification, right? So that's very important here. And this is how one-click LCA can perform a whole building life cycle analysis. You have to have your bill of quantity with a specific manufacturer requirement, right? Then we have carbon calculators, carbon designer 3D. Again, it is from one-click LCA. Let us see that. So carbon designer 3D, it's like initiating your building design with an idea of its environmental impact, right? So I'm going to construct some 10-story building, again A, B, C. So here they have the reference building. It's location specific, you can see. Spanish, Norwegian, Japanese, Middle East. Even for Middle East, they have the reference standard, but there is no Indian specific. So we prefer international reference building. So type of building, apartment building. What's the grass floor area? You can enter. Calculation period, you can enter. And again, what are the elements that you want to involve, so that you can choose and you can unselect. How many number of stores, what is the structural frame? So in situ concrete beam, or precast, or steel frame, or timber based, so that you can select. And this is the geometry data of your particular building. So what is the total height? You can adjust here based on your actual building data, right? So once you put and calculate the areas, it would calculate the areas of the different building components, starting from the foundation to ground slab structure, floor slab area, column, all those things it would calculate. It's like based on these, the left side input, this is being produced, and this is like a visual representation how the building looks like. That's all. And finally, if you submit, it would show you it's getting loaded. So this is what you will get. So for your given data, 803 kg CO2 is going to be emitted. And which are the elements is participating in different quantity? This is it. Like uh, external walls, and here internal walls are based on your input only. We haven't edited anything. It just had its own inputs. So this is how it would come under. So by material also, you can understand which material contributes to the maximum carbon footprint. So by having this idea, now you can optimize your design effectively in BIM or some other design softwares. And again, if you once you optimize and re enter those optimized values here, then you can understand how much amount of carbon has been reduced. So this, it's like before initiating your design, actual design, you can have some tentative idea of its futuristic carbon emissions, right? So that you would be very cautious while performing the design. So that's the ultimate objective of this carbon designer. Then kaleidoscope, carbon calculator. Kaleidoscope, as I mentioned, it's meant for only kaleidoscope calculator. So this is it, and you will have that envelope, flooring, ceiling, and partitions. So if you click the envelope, it would list all the envelope materials available in that particular market. So as I mentioned, these and all are meant for the Western world. Mostly these materials won't be available in India, cannot be available in India. So all things have been selected here, right? So if you unselect, everything would go under. So insulated metal, if you want to choose, and if you want to compare that insulated metal against terracotta based, now you can understand. So metal based insulation, this much emission is there, 13.25 kg of CO2. What about terracotta? Only 8.17, right? So that's what this particular tool is meant for. By doing this comparison, you can make your effective choice. That's it. Nothing else. It won't take much data or time, something like that, right? So that's the point of kaleidoscope. Then EC3 web applications. Kaleidoscope, it's not like a web application, but still it's a website of database. EC3, it's like a web application. So EC3, we can have EC3 calculator. So it is highly meant for the global embodied carbon database. So we can say it's all are open source, nothing you need to pay or nothing like that. Everything is available. And you just need to give your login ID with some approved mail. That's all. So this is that web application tool of EC3. And I want to mention an interesting point here. A person who is having 2+ years of experience in this EC3 tool is paid, right? Today is paid worth of 45,000 to 60,000 Canadian dollars per year. That's the scope of this particular tool, right? So if you go for a job, life cycle assessment expert, you learn this and get some experience, go to Canada, become a billionaire. That's all. So what are the things are there? You can plan and compare your buildings, right? You can like how the Edge app looks like. Similarly, this particular feature would enable you to prepare the drawing and prepare the building and compare the buildings as well regarding the embodied carbon of different materials. And very importantly, find and compare materials. For this only, this particular portal is mostly preferred. So as I mentioned, all the construction materials will be available and in all part of regions. And we may not able to know, whether the particular region is having some material listed here or not. For example, let us talk about concrete. So it would, this much concrete comes under, okay, ready mix concrete. So I want EPDs of ready mix concrete. So what I have to choose is geographic. Geographic, they mentioned as global, like international, right? So here I make it very specific. Asia, Southern Asia, India. If I click OK, it would come under for only in India. So it would list all the environmental product declarations of concrete products from India, right? And if you click search, it would come with the result. There is no EPD from India on concrete, right? So what if you put a global? global, if you put and search, you would have, 70,000, around 71,000 EPDs of concrete products. So for example, this particular one. So you open it and it would open in the another page, and you can able to see what is the 1 meter cube of that particular concrete would emit. So this particular 401.0 kg CO2 will be emitted. So this is the data, right? So unfortunately for India, we don't have this, but still we can refer this for the respective product, right? So only thing is, India is not producing such product or no. We are the second largest producer of cement and concrete in the world. So we are not yet adding our EPDs into the portal. That's all. That is what the gap is. So don't think that India is not going towards the greenery path. No, we are doing good things, but the EPDs are becoming the core component of all these embodied carbon calculators and the software tools. So once you upload your EPD or register your EPD into the international portal, all those EPDs will get synced into all these tools and your product will be listed here. That's the only thing, right? And that's what you should understand. So by seeing this, you can understand, this is what I told, LCIA method, different LCIA method are there. So here this particular product has used the TRASI 2.1 LCA method. And you can see the environmental product declaration of that particular concrete product. Yes, download. So this is it, right? So this is that how to say EPD of that particular product, right? So here you can able to see all those environmental impact data from the material procurement to the construction. So that's the meaning of environmental product declaration, right? And by seeing this, you can able to understand the environmental impact of that particular product as that concrete, right? So EC3 tool works this way only. So you can able to search and compare concrete, masonry, steel, aluminum, everything, right? All those things with the specific of global or specific location. And lot of analytical information should be there, which means those values, what is the standard deviation, how much dependable it is, all those things are available in the same portal. If you explore this inch by inch, you can understand, right? So next one, Revolu. Revolu is specific for again Scandinavian countries. But as I mentioned, 25 Indian products has been listed in Revolu. This is also is a growing embodied carbon database, which is being preferred across the globe, right? So very, very uh, uh, good thing about this. You can see all the data. So it's all materials, right? So you choose a country specific. You can go country specific. India, 25 materials are there. So these are the 25 materials listed in Revolu from India, right? So top coat, like paint and carbon tiles, this particular product, carbon tiles. So if you click that, it would come like this, so that you can able to see what is the global warming potential of the entire product. So 0.285 kg, that's all, very, very least. So it's EPD validity also they would mention 2028. So how this value is being displayed, it is only because of the EPD, right? So you can download the EPD as well. So carbon tiles is the India's first carbon negative floor tiles for the interiors, right? And they are going global. That's a good thing. So this is it. This is how the EPD would look like, and you can able to see all the product components in each and every stage from A1 to D, right? And everything they would have described and listed, right? So see, can able to understand results per functional unit. 1 kg of carbon tile from A1 to D, this much emission has been made. So, right. So that's so this is how a typical EPD look like, and the references they would mention, right? So once you have this EPD for your product, your material will be listed in all these global platforms, and you can push a green designing in India, because we don't have much EPDs, right? What's the next one? EPD hub. So all these tools are integrating the data from this EPD hub only, right? For your information, EPD hub is the centralized international EPD platform. So in EPD International, there will be EPD portal. You can go and explore the global level. Oh, I think they are asking. Yes, this is the EPD portal library. So you can go for the company name, or if you know any EPD number specifically, you can select product category, geographical location, very importantly, right? So country specific, India. We don't product category as well as obviously construction products, India. If you put search, it would list all the construction product and uploaded EPD, available EPD. What is this? Metal framing. So this is a metal, this is a product which is being provided by Saint Gobain India Private Limited. And they have uploaded this particular, which means they have published their EPD in the EPD International System. Is if you click, you can able to see the validity, EPD owner, and all those contact website detail. So which means this is the manufacturer data. So you can go and make your order like that. So this is the EPD of that particular metal frame, right? So if you see this entire EPD platform for India, so it is showing first 50 most recently published. If you keep on scrolling down, it would list all the different construction based products from India. So it would keep on, the increasing in numbers. So totally you can able to find out some around 150 EPDs from India has been registered. That's all, only 150. Right, we have larger manufacturer of steel product, right? Tata, we have cement producers are there, world level contributors are there, but still we are, inching towards being the like what to say, uh, chief practitioner of construction material, right? So because concrete and steel is a matter of Asian continent. In European continent, they don't prefer concrete or steel as much as that we prefer. So they focus on only that wooden based aluminum and other lightweight based materials only, so that they can immediately innovate, they can immediately establish their EPDs, and they can keep on moving forward in the net zero goal achievement. But with the Indian condition especially, we are highly depending on concrete and steel, very heavyweight materials. And for those materials, we are highly lagging in getting the EPDs. Right. So that's the thing. solar grid, we have agro grid, very important material from India, Visakhapatnam. So that's what you can see. Finished long products, steel. So as I mentioned, steel products are getting their EPDs. Mostly the paint, other accessories would be listed here. So I told 150 products only are there. From those 150 products, the majority of the material is not cement or concrete or steel. It's like paint, cables, and other those things only are listed, right? So it's keep on getting increased day by day. That's a good sign actually, right? So if you that's the list. So if you calculate how many numbers, you can understand that many products only are there from India in EPD portal. So if you want to reflect your research-based product into this green building revolution, you have to go and obtain the EPD of your product by telling what are all the energy consumption and emission respective for your each and every process involved in that product. For example, there is an IIT Madras, IIT Indore. They develop some new product. What they will do, they will go and obtain the patent first, and they will call for commercialization. We are open for commercialization. Come on, like that. So it's like a huge gap between academic research outcomes and the actual industry practices. So this is the newer and emerging pathway where you can put your product directly into the manufacturer's visibility, or industry practitioner's visibility is by getting the EPD for your product. Whatever the product you make, right, you develop as a project of your undergraduate or postgraduate or research. If you can able to get your EPD and get it published, then your product can be listed here and would be visible by the industry practitioners of today, right? So it's like a new pathway of getting commercialized with your research outcome. That's it, right? Finally, ID mat. So ID mat, let me share the screen here. The screen visible?
Yes, sir. Yes, sir. It's visible.
Yes, fine. So this is that ID mat app. So you will initially have two options. Just a minute. Location on screen, what you see?
Sir, no, sir. Now it's not visible, sir.
Only screen is visible, right? That
Yes, sir. Yes, sir.
Teams. Okay, fine. It is actually bit slow.
Okay, sir. Okay, sir.
Yes, fine. You can actually try on your own because it's getting too slow. Right. So it's a free Android app only developed by Delft Technological University, Netherlands. So it would have the materials processes involving in any construction like concrete development or any particular processes involved, all those things. So if you simply click that material, that would be added into a project. So in a project, if you keep on adding whatever materials and processes involved, then finally, if you put a result, it would showcase all the cumulative CO2 emission for your intended process. So I actually published one of the paper by using that particular IDMAT app. You can put IDMAT light LCA elsewhere. If you put that paper will show up and you can refer that also, right? So that's it. These are the things that we have currently and in contemporary scenario of embodied carbon and low carbon building materials. So finally, before going into the takeaways, I would like to show what ChatGPT has to say about that embodied carbon, because we nowadays ask everything and anything to the chat GPT, right? So let us see how it what it responds for questions regarding embodied carbon. Just a second. Is the screen visible?
Yes, sir. The screen visible, sir.
Yes, fine. So
Okay.
I have asked ChatGPT to calculate embodied carbon with the concept of carbon conversion factor and material quantity. So it shown some example for steel beam. So quantity of steel beam 1000 kg, conversion factor 2.5 it mentioned, and it calculated multiplying those two and told me total embodied carbon 2500. So I asked how you got those carbon conversion factors. So it immediately apologized. I apologized for the oversight. Let me revise with the actual conversion factor. So it immediately referred from authenticated sources for the conversion factor of steel beam. Earlier it used 2.5 as the conversion factor, then it used 1.8 as the conversion factor. Then it calculating the embodied carbon and finally showing the total embodied carbon of that particular steel beam, right? Then I asked, can you calculate for the plastic waste embedded paving block using the same method? So it told for the plastic waste embedded paving block, I don't have the conversion factor. So that's the issue here. So it assumed the conversion factor is 1 and it calculated the value. Then again I show, can you show the detailed calculation of the embodied carbon M20 concrete with the conventional ingredient? So it shown all these things. That's what I actually presented in our slides, right? So cement, fine aggregate and coarse aggregate. And for each of the conversion factor, it referred from the authenticated source. That's the highlight here. So it is dependable, right? So substituting value for water, there is no conversion factor, and accumulating all the embodied carbon, it summed up, right? 316.4 kg of CO2. Can you revise the calculation if I add steel slag as 20% replacement for the cement? Because this is what we do as a research for coming up with some low carbon material, right? So it mentioned steel slag 20 percentage, fine, but again it doesn't have the what to say, the conversion factor of the steel slag, embodied carbon conversion factor for steel slag. It doesn't have. So it assumed 0.5 kg as it is and calculated and show me the what to say, the final total embodied carbon. So by using chat gpt also you can have some basic and very preliminary understanding of embodied carbon of different materials. Like that you can do the same conversation with your intended combinations of waste material and other things, because most of the times we assume that if you are incorporating more waste, your final product is lesser carbon intensive. It's not that. You have to use the right combinations of waste materials, because the transportation matters. That we have seen, transportation is the very important module in the embodied carbon calculation. So if your waste product A comes from some 500 kilometers away and waste product B comes from some 5000 kilometers away, and putting it and bringing a new product, you call it as a low carbon material? No. Already in the transportation, huge amount of CO2 emitted already, right? So you should not presume that all the waste materials incorporating into a new material can become a best low carbon material. No, it's not, right? So that's the very important understanding. And final key takeaways, decarbonization has multiple routes, and finding the embodied carbon value is the first step to begin the decarbonization pathway, right? Then it can be calculated by multiplying the material quantity with the carbon conversion factor. And for that conversion factors only are being fed into computer program and serving us as web application or software. That's it, right? Nothing else. As our colleague says, all the life cycle assessment softwares and tools are nothing but advanced Excel sheets. That's all, right? So you need to have the conversion factor. From software, web apps to mobile apps, Western world data are overwhelming. That's the huge drawback for the Eastern economies. For building materials embodied carbon, and Indian scenarios are still under emerging state only. So as we have seen, 25 products only are there in Revolo, and only some 150 products are there in EPD International Portal. So we are just emerging, and we are growing steadily and day by day. That's a good sign. More registration with the global EPD platforms can help in reflecting Indian originated products in these tools. So what will be the benefit of getting registered with more Indian based EPDs? Our LCA results and embodied carbon calculations will become more accurate day by day when we have more amount of Indian based EPDs in the portal, right? So that's it. Any questions we can have? Lokesh, any question?
Sir, only one question, sir. One member asked, please share the Excel sheet. Like,
That
sir,
is,
in the first,
yes, I understand. That is available in open source only, inventory of carbon and energy. You simply put inventory of carbon and energy, you will find the that website carbon ecology, something like that. So you can put your email address and all those things. It would available for a download. Nothing serious. Yes, any other question?
okay.
Yes, have you shared, please, the feedback link you please share. I request all the participants, those who are available, please, provide your feedback. And based on that, we would refine our upcoming webinars, focusing on low carbon strategies as well as sustainability as a whole.
Hello, sir.
Yes. Yes, please.
Actually, it was a very good section.
Okay.
We got for me it's very important because just now I thought of studying more about this environmental terms, and you give a very nice what to say, very concise and good presentation. If
Thank you.
in next webinars and all. If I get some more practical examples like that, then it will be more easy to understand. That's what I have to say, sir.
Yes, we understand, we accept. We will be working on that.
Okay, sir. Overall, it's a very nice and useful presentation. Thank you, sir.
Thank you. Any other comments, questions? Okay, Lokesh, you try to stay until some 1 o'clock, right?
Yes, sir.
Then we can wind up.
Okay, sir. Okay, sir. I will pray.
Fine.
Thank you, sir. Thank you for your presentation, sir.
Fine. So then after, while you leaving, you stop the recording.
Okay, okay, sir. Fine, sir.
Fine. Sharply at
Thank you,
1
sir.
o'clock. Enough.
Thank you, sir.
Fine. சொல்லுப்பா